When you move into a new house, one of the first things you do is get to know your neighbors, because it's always nice to have someone to help you out in case of an emergency, or just to get to know and understand the neighborhood you live in. In a similar way, scientists have set out to acquaint us with our neighbor in the Milky Way, Mars. We found out the rocky red planet is half our size, yet scientists at the European Space Agency wanted to find out more. So, the Mars Express was launched on June 2, 2003, to research the red planet's atmosphere, climate, terrain, and water content in various forms. The €300 million mission consisted of 7 main tools observed from various parts of Europe and the US. A high-resolution stereo camera is used to map the surface of the planet in color and 3D. An energetic neutral atoms analyzer to analyze the interaction between the particles in Mars's atmosphere and the solar wind. The planetary Fourier spectrometer assesses the atmosphere's composition and temperature in various points of altitude. Visible and infrared mineralogical mapping spectrometer maps the mineral composition and ice surface of Mars and characterizes the atmosphere. Subsurface sounding radar, altimeter, investigates the subsurface of Mars. The radio science experiment checks the distortion of communication between Earth and Mars due to the atmosphere, Mars's gravitational field, and also reviews the terrain of Phobos, the larger of Mars's moons. Lastly, the ultraviolet and infrared atmospheric spectrometer observes the composition of the atmosphere, specifically the ozone, water vapor cycle, aerosols, and thermal profile of the atmosphere. Since its landing in January of 2004, the orbiter has been quite insightful about our curious neighbor. It has provided images and the mass of Phobos, as well as more accurate orbit measurements of the 2 moons. It has presented new information on the planet's landscape. It has also given us maps of water and carbon dioxide ice at the poles, evidence of water on the planet in the past, and eventually the evolution to a colder, drier climate with only surface water through the existence of phyllosilicates, sulfates, and iron oxides. The orbiter found that the planet's atmosphere consisted of supersaturated water vapor, molecular oxygen night glow at the poles, a vertical distribution of carbon dioxide, and possibly methane via chemical map. It has shown the recentness of the volcanic and glacial processes. The mission has also helped produce ozone and temperature maps and so much more. One of the mission's latest finds is a record of tectonic stresses and strains found in the ridges and troughs experienced in the Archean Fosse area, 3.7 to 3.9 billion years ago. Originated from the Tharsis Bulge, the series of cross-cutting fractures indicate that there were several stresses from different directions. The hot substance gushed from the core, and volcanoes formed, in turn pulling the crusts, creating craters surrounded by faults and elevated terrain. This is quite similar to continental rifts on Earth. This is important to study so that we can evaluate the evolution of the outer crust and the thermal evolution of the subterranean layers. The mission consisted of an orbiter which contained the 7 instruments, and a lander called Beagle 2 to survey the terrain. Even though Beagle 2 mission was declared lost on the 6th of February 2004, the Mars Express orbiter still orbits today, helping us out with the inspection of Mars. This mission is vital in getting to know our neighbor and Earth better, as well as understanding our role in our neighborhood, the Milky Way.
Created using Powtoon.